let's proceed with another type of ordinary differential equations, which we will call exact ODE, exact ordinary differential equations. Okay, so what are these? So when can we say that it is an exact ordinary differential equation? Okay, so say for example, you have a function equation composed of functions of x and y. Okay, and then if you want to get the total differential of this one, so total differential is denoted by this one. This is just equal to the partial of u with respect to x dx plus partial of u with respect to y dy. Okay? And then so if this equation is equal to a certain constant, okay, so what would happen to your differential equation? This one would be 0. Okay, anong 0 man? Okay, let's illustrate this one. Okay, you have u is equal to x plus x squared y cubed, and then this is just equal to certain constant. Constant meaning it can be any number that is constant. Okay, if you want to get the total differential of this equation, du is equal to partial of u with respect to x. So you have 1 plus 2xy cubed. Okay? Multiplied by dx plus partial of u with respect to y. So you have 3x squared y squared dy, and then this is equal to 0 because the derivative of constant is 0. Okay, so you will now get this equation. Okay, so if we rearrange this one, now this whole term is, what is this one? This is an differential equation. Okay, this is a differential equation. Now this is of the form m dx plus n dy will equal to 0. Okay, we let this whole term to be m and this term to be n. Okay, so when can we say that it is an exact differential equation? So there's a test for that, no? There's a test. And the test is that if you take the partial derivative of n with respect to y, meaning if you get the derivative of this one with respect to y, it should be equal to the partial of derivative of n with respect to x. So this must be satisfied. Otherwise, you cannot use the method for exact ordinary differential equations. Okay? So in order to solve the general solution, if you are given an exact ordinary differential equation, so let's have an example. By the way, the concept of finding the solution for exact ODE is that parang i-reverse mo siya. Okay? Ito yung given sa problem, and then you will try to solve this one. Okay? Parang i-reverse mo siya. Okay, let's have an example. Let's have an example. Let's start with an easy one. Okay? Example number 1. You have y squared minus 2x dx plus 2xy dy equal to 0. Okay? Okay, first thing you will do is determine what is your m. So this is your m, this is your n. And then next is test for exactness. Okay? So m is equal to y squared minus 2x and n is equal to 2xy. The partial derivative of m with respect to y, meaning you let x be a constant. Okay, so 2y. And then partial of n with respect to x is equal to 2y. Okay, therefore this is an exact ODE. This is an exact ordinary differential equation. Okay, once you satisfy this criteria, you are now ready to proceed to the next step, which is, okay, by the way, a partial of u with respect to x is equal to m, right? If you recall from the introduction, no? And the partial of u with respect to y is equal to n. Okay? So either way, you can use this one or you can use this one. Say for example, we use this equation, partial of u with respect to x is equal to m. Now the u here is your general solution, the general equation, which wala kakabala na. Okay? But we can integrate this one, and partial of x. If we integrate this one, we will get u is equal to the integral of m, or we can change this one to the derivative form, plus k. Kung sa maning k, this is your constant of integration. Okay? Constant of integration. When you integrate this one, you need to add the constant. Okay? So therefore, your u is just your m, this one. Integral of y squared okay dx plus k. Okay, so may you set the variables containing y to be a constant. Okay, so this will become x y squared minus x squared plus k. Okay, now so this is now your general solution for your equation, but napa may kulang kining k. You do not know what is k, so you need to add additional step. There's an additional step. You need to find the value of k. So saan pakuha? We will differentiate u with respect to y. Okay? U with respect to y. Okay, if we differentiate this one with respect to y, we will have 2x y minus kani, there's no y, so 0, plus tama ba? The derivative of k with respect to y. Derivative of k with respect to y. Okay? So, mauna siya. And then, if you recall, kung saan isang term, this is actually your n. Your n. This is n. And therefore, this is just equal to 2xy. 2xy. Okay, so cancel out ni sila. Therefore, your is equal to 0. Okay? And then integral of this one, if you integrate this one, you will find out that k is just equal to constant. Okay? K is just equal to constant. Therefore, this one will be u is equal to u is equal to x y squared minus x squared plus c. Okay? Or if we will transpose the c, this is just equal to x y squared minus x squared is equal to c. Okay? So this will be now your general solution. Okay? That is kung kanino ang gamiton. Also, you can use this one, no? And still arrive to this answer. Okay, let's illustrate that one. Okay, let's illustrate that one. And hopefully we'll arrive this answer. First is have partial of u with respect to y equal to n. And if you integrate this one, you'll get u is just equal to integral of n dy plus L, constant of integration. Okay, so u is just n. So xy dy plus L is equal to x y squared plus L. Okay? And then let's evaluate what is the value of L. Now, if you use this one, so itong ibuhat na ito kaganihan, we differentiate this one with respect to x. But since we use this one, we will now differentiate this one with respect to y. Okay? No? Lahi na sila. Therefore, you will get du over dy bali di ay kaganiha we differentiate with respect to y karon with respect to x bali respect to x du over dx is just equal to y squared plus dl over dx. Okay? And then, kaninga term is just equal to m. So, we will equate this one equal to m. So you have y squared plus dl over dx. Your m is this one, y squared minus 2x. So cancel. Therefore, is just equal to negative x squared. Okay? Butang ba bakal plus c? Dili na. Because naamang yapon ni pinalasan, ibutang nimo. So, combine na sila kanan. Okay, and then substitute this one direct valid. Therefore, your u is less equal to x y squared plus L negative x squared equal to c. So they are just the same. So you can use either of these two, but you must follow the right process. Okay, let's have another example. Okay, so let's try this one. X cubed minus squared y plus y cubed equal to x cubed minus 6x squared y 3x y squared. Okay, 2x cubed 6x squared y plus 3xy squared. Okay, so sa may unang buhaton ni morning. First, arrange this one so that you will have this form. Okay, so let's arrange this one. So you have 2x cubed minus plus 3x, okay, minus okay. This is now your n, this is now your n. So let's have the test for exactness. Partial of n with respect to y is equal to partial of n with respect to x is equal to respect to x. Okay, therefore they are is an exact quantity. Then after the guys na on. We use this one. U is equal to integral of n dx plus k. Sometimes they put k of y. Okay, so u is just equal to m to x cube minus dx plus k of y. Okay. Integrate this one with respect to x. So you have 1/2 x to the 4th minus 2x cubed y plus plus 3 over 2. 3 over 2 x squared y squared plus k. Okay, this is your u. And then after that, we differentiate this one with respect to y. Differentiate with respect to y. Okay, you will get this one. Du over dy is equal to plus this is just equal to n. Okay, this is just equal to n. So your n is plus y cube. Okay, so kasama cancel out. Ni. Therefore, your derivative of k with respect to y is equal to negative y cube, or k is just equal to negative y fourth over 4. Okay, and then we substitute this one back there. Okay, so kung reason for your u is just equal to plus, or rather minus, equal to constant. Okay, so this is now your general solution. Let's have another example, and plus x dy is equal to 0. Okay, so again, let's test for exactness. Partial of n with respect to y is equal to negative 1. Partial of n with respect to x to 1. Okay, so partial of n with respect to y is not equal to partial of n with respect to x. So this is an example of non-exact ordinary differential equation. So what do we do? Okay, there are times wherein you can reduce this one into a separable or into an exact ODE. Okay, So how do we do that? We multiply a certain factor. Okay? So, say for example, we multiply it by 1 over x squared. 1 over x squared. Okay, so may tabuan eh. This will become negative y over x squared dx plus 1 over x dy is equal to 0. Okay? Okay, we test for exactness. You have partial of m with respect to y equal to negative 1 x squared. Partial of n with respect to x equal to, and this one is x negative 1, x negative 1 is just negative 1, x negative 2, or this is just negative 1 over x squared. So, apparently, this 2 now becomes an exact differential equation. Okay? And then, you proceed with the getting the general solution. Okay, the question is, how do we know this one? How do we know what to multiply? Okay, so there is a method for that in knowing what to multiply for a certain differential equation to make it an exact differential equation. Okay, so let's erase this one. Okay, and let's find out how to get the integrating factor or the expression that we multiply to the differential equation. Integrating factor. So how do we get that one? M dx plus n dy equal to 0. Okay. Now if we okay, let's change the variable. Instead we use p. Okay, this is just the same. Now what we did is we multiply this one by a factor f. Let's say it's f. This becomes f p dx plus f q dy is equal to 0. And then to be exact, we use this one, right? Partial of m with respect to x, y. So let's apply this here. So you have partial of f p respect to y equal to partial of fq respect to x. Okay, we are trying to get a different integrating factor f. Ano sa value ng f? para ma-multiply na to para dili ta mag trial and error. Okay? Okay, so using product rule, you have second the first plus first the second. Okay? Is equal to second the first plus first the second. Okay? Now, in terms of y, in terms of x, yung integrating factor is in terms of y. So to make it simpler, okay, we let your f be function only of x. X lang. So sa may tabo sa imo ang fy. Derivative of your fy means f sub y means derivative of f with respect to y. But since ang f nimo function of x only, so this becomes 0. So simplify na ni karon. Okay? So 0 na ni kani. So this becomes f p sub y is equal to fx f sub x. Okay, as a meaning ng f sub x. F sub x is partial of f with respect to x. Partial of f with respect to x. Or let's say this is f prime. May man ning f prime karon. Okay, ayaw mo ka-confuse ha. Ang atong ginabuhat ra diri is try to find unsay value aning f. So f prime q plus f q sub x. Okay, divided by, let's divide this one by f q. So sa metabuan ni we have py q is equal to f prime over f plus qx over q. Okay, so df over dx. Tama. Again, f prime is df over dx. Okay. Tuning simplify. fq. Oh no. Let's transpose this one to the right side. F prime over f is equal to py minus qx over q. Okay. This is just equal to 1 over f. F prime is derivative of f respect to x na mga g. One over f derivative of f with respect to x is equal to 1 over q py minus qx. No. Okay. P sub y is just derivative of p with respect to y. Okay, and q sub x is derivative of q with respect to x. Therefore, maning dp over dy minus, okay, so okay. Diretso na lang ko niya. I will erase this one, and then let's rename this whole term as r. R na siya. So this becomes, your integrating factor now is 1 over f is equal to r. Okay? Okay. So you have nakidwa ka theorem ani. Theorem number 1 is that if your r kaninga term is composed only of x, meaning kung kaninga term ang variable only is x, you can, ang integrating factor na niya, integrating factor is f is equal to e raised to r of x dx. Okay, yun sa'yo pasabutan ni. Kung ang imong r kani nga term composed only of x variable, mo na ni ang imong i-multiply sa expression. Okay, man gikuha ni siya by gikan na dire. No, you integrate this one, and then erase nimo to e. Ano nakuha nimo ni siya? Okay? Ano siya? Theorem number 2. Theorem number 2. If okay, nakuha na ito ng expression because of this assumption. Now we let the integrating factor be a function of x only. Now what would happen if we let the integrating factor be a function of function of y. Function of y. So, may tabuan na rin na okay. Kung function siya of y, ang imong makuha nga integrating factor is 1. Lang nato na yung chart. Para dili ka ma-confuse, no? 1 over okay, so this is now your for theorem number 2, wherein your integrating factor the function of y only. So ang value for daning r is equal to 1 over p okay. I think murag baliktad ra siya. And then correspondingly ang imong integrating factor karon, okay, condition ani niya is that if r is a function only of y is equal to e raised to r sub y dy. Okay? So, mo na imong integrating factor. By the way, kani nga discussion, naara ni sa basic nga book. So, just look at, basahan na sa libro. Okay. So, mo na siya. No? First is, ang R ni mo dapat function of x or function of y only. Now, kung in the event niya, pagkuha ni mo ani sayang r dili function of y but mix, so dili ni mo magamit ni nga method, you use another method. Okay, let's have an example. Have an example. So this one is e to the e to the x plus y plus y to the y times e raised to y dx plus x e to the y minus 1 dy is equal to 0. Okay. So first, check for exactness, no? So this is your P, this is your Q. Partial of P with respect to Y is e to the U du plus 1. Diba? Ano? E to the U derivative of U respect to y. 1 plus first the second plus second the first. Okay? Muna siya. E to the y. And then partial of q with respect to x is equal to e to the y. Okay? So, dili sila equal. They are not equal, they are not exact. Okay, so sa bato naman again, try to multiply an integrating factor. Okay. Let's apply theorem 1, no? Check na to kung pwede ba ma-apply ang theorem 1. Kung sa ganitong theorem 1, your integrating factor must be function of x only. Okay? So, saan yung pagkabalo? So, you use this one. R is equal to 1 over q partial of p with respect to y minus partial of q with respect to x. Ano siya? So, what is your q? Ano yung q? X e to the y minus 1 ay 1 over na din eh. Okay, 1 partial of p with respect to y. So, kani respect to y is a to the x plus y plus ano minus partial of q with respect to x. Okay. So, as you have observed, na ay x, na ay y. So, therefore, this is not function of x only. So, theorem 1 cannot be used. Let's proceed with theorem 2. Theorem 2. Theorem number 2. Theorem number 2 is that your integrating factor must be a function of y only. So, say ang r niya. Your r is actually r asterisk yung 1 over p partial of q partial of x minus partial of p partial of respect to y. What is your p? This 1 over partial of q with respect to x. So you have e to the y. Then minus e to the y okay. So cancel na eh. Ang na lang is negative e to the x plus y e to the y Roman. And then 1 over e to the x plus y plus y e to the y. Therefore, cancel out din eh. This is equal to negative 1. Okay? Function ba ni y? Dili, no? Pero constant. Pwede gyapon siya. As long as walay x. Therefore, pwede ang theorem number 2. No? So, using theorem number 2, your integrating factor would be f is equal to e raised to r of y. R of y is negative 1 d1 kaniya. R of y. Therefore, negative 1 eh. Mahimo running a to the negative y. Okay? E to the negative y. So, mao ni ang imo ang i-multiply sa imong expression. So that it would become an exact differential equation. Okay? Okay, so let's multiply. We'll now erase this one. Let's multiply that one into the expression. Okay? So if we multiply this one with e to the negative y, what would happen? You have e to the x plus y dx plus x minus e to the negative y dy is equal to 0. Test for exactness. So partial of p with respect to y is equal to 1. And then partial of q with respect to x is just equal to 1. Okay? Therefore, equal na ni sila. This is now an exact ordinary differential equation. And then once you get this one, we proceed in getting the general solution. Okay? Again, u is equal to integral of m. So this is now your m dx plus k of y. So e to the x plus xy plus k of y. Okay, and then differentiate this one with respect to y. So you will get x plus derivative of k. Again, this is just equal to 1 minus e to the negative y. Therefore, cancel out. Since isa na lang na variable, may mo na niya siyang pwede na sa imong derivative. Okay? Therefore, ang answer ani is decay aray. Naman po ka mo. Okay. Is equal to negative e to the negative y dy. Okay, ang answer ani, if you integrate this one, you will get e to the negative y. Okay, plus c. So, na ito mag-plus mo ito later on sa at the end of the expression. Okay? Pwede gana kung mag-plus c dire. Anyway, i-group run man mo together. So, substitute this one here. So, you have u is equal to u is equal to e to the x plus xy plus e to the negative y is equal to c. This is now your general solution.